Now we're moving to the next presenter with the title Acceptance and Shipping Warehouse Zones Calculation Using Serverless Approach by Alexander Mullerevich. Alexander, are you here? Alexander, I see you in the chat.
Yes, hi, but I'm not sure I will be able to share my screen because connection is too poor, so it could be laggy. Maybe if it's possible, you can start YouTube record that I sent in channel.
Okay, I will share the screen right now. Okay, and afterwards, if there are some questions, you'll answer them. Okay. Just 1 second, please. Can you see the screen? Yep.
Yes.
Is everything okay? Okay, so let's go.
This conference. My name is Alexander Mullerevich. I'm a PhD associate professor at the Department of Electronic Computing Machines in the Mathematician University.
Your voice. Don't hear.
Accept.
I can't make it louder, unfortunately. So this is the version of the video that I have. I cannot make it louder. Let's try maybe for another several minutes.
Short overview of main points. They are introduction, objective of research, warehouse design problem overview, acceptance and shifting zones simulation, develop model of system, search for an efficient, scalable, high-performance computing approach, and conclusions. So, motivation and state result. Warehouse operation is one of the main problems that appear for different industries.
Oleg Alexandrovich, don't hear you.
So as far as I can understand, the voice is not here. Yeah.
Yes, yes.
But I can't do anything with it, so I have just this presentation. And Alexander, maybe can you try to deliver your talk?
You mean to start with mobile network? I could, but I'm not sure it would work.
Let's try. Let's try.
Okay.
Alexander, can you share the screen?
Yeah, I struggle with sharing my screen.
Okay, yeah, there was a good suggestion. Maybe Alex, you can talk while video would be playing muted from my side as well. So you will see, all of us will see the video and you will speak.
Yeah, it could possible.
Okay.
Because I can't share screen. I don't know why. Some permission issue.
Okay, the permissions are open for everyone. So Yeah, thanks, Alex, for help. Okay, I'm muting the video. And okay, let's go. Alex, please.
Yeah, so in general, why this search was started is because the main issue for any e-commerce industry, like producers or some online shops, always stay storage space dedication, goods flow transferring and routing, and it's very hard and complicated tasks. So it's very popular to outsource this problem for some third party, so named third-party logistic providers, or shortly named 3PL. Each 3PL provider has a set of own warehouses, buildings, and from time to time, the usual task is to design new warehouse or reorganize existed one. The main criteria is make it as fast as possible in reliable time for customers to win competition with other companies also involved in industry of 3PL services. The main approach that mostly is used for all of them is manual calculation, usually done by the team of logistic engineers with some support stuff like Excel tables, formulas, and so on. Another one kind is also partly manual, but with some developed system and additional tools that help a bit automate. But the main problem is that any of such tool requires high level of expertise and huge time for education, and they are not universal as it could be. What are the main disadvantages of manual approach? Calculation is for sure possibility for human failure. The requirement time in such case for complicated case of warehouse design and a lot of different combination is required time for months or even more. And there is no guarantee that the team of logistic engineers with some input data and condition could prepare reliable solution like the optimal one. Objective of research is to demonstrate the methodology of calculation warehouse design as it's done in current article only for inbound outbound part like pre-processing of order set and constraints as one phase, and the second phase is the parameters combination generation and optimal cost search. So we used in our system prediction neural network model for guessing the potential optimal combinations, and parallel based on cloud computing technologies computation part. Also, we provide some research in possible variation of using different computing approaches and demonstrates all benefits of developed model and designed computer system based on it for warehouse design problem. Maybe you can somehow switch further for the next line. I just want to speed up a bit to not waste your time. Yeah, just another one. Yeah, thanks. The typical warehouse zones are next. It's unloading and acceptance zone, storage and collection zone that is also named like replenishment, control and picking zone, usually combined with packaging, transportation expedition zone, where our transporters are parked and execute during processing time internal orders, and shipping zone. By the way, acceptance and shipping zones are usually combined in one area. The next one. Just maybe click it further. Yes, thank you. The input data usually looks like the set of orders accumulated for the past year or maybe several years. It consists of orders, so named order line. Each one order line is a product with required number of volume, packaging unit that it should be packed, and information of target customer, how all they are combined, like shipping date, due date, start order execution date, and some other additional stuff. Based on that data, we could, using also expectation of customer, like extrapolation criteria, forecast and prepare criteria of future possible order volume. Here is example like expectation of order volume for fiscal year, like 4 quarters. It's just example sample, but it demonstrates how we work with data. Yeah, we could move a bit further. Yeah, and here is short of overview of methodology after pre-processing of data, how we define the size of acceptance and shipping zones area. They consist from area volume and area square occupied based on used racks or lefting it as a bulking area. The target is to calculate area sizes and considering potential shipping and acceptance time time shifts required for execute all orders. We could evaluate how much gates we need. It also includes vehicle parameters for this evaluation and some information about potential packaging units that should be used. All that information is publicly available. It could be provided by customer, but it's also available from different bulletins. Next one. Here is example of result evaluation from some sample data. So as a result, we will have size of area, some rack placement, and defined number of gates, considering vehicle criteria and constraints. Here we have 7 gates devoted fully for shipping processing and 3 combined, as we have combined acceptance and shipping zones. 3 of them are used for both outbound and inbound. We just have split these procedures in time. Yeah, why actually we have this problem complexity? Because just from example, we will not show all constraints. There are much more, but the main one from these examples that we can see, there are 4 different possibilities for placement of gates in a building, like 4 combinations, separate or combined mode of placement in acceptance and shipping zones. It's another one to combination, acceptance vehicle type. It could be 10 and of course more. The same with shipping vehicle type and transporter type required for internal order processing. It also, in this example, it's 5. So only with this sample simplified data, we need in general 4,000 of combinations. Yeah, and here is demonstration of model actually architecture of our system. Proposed first of all, we split pre-processing with combination evaluation. Data pre-processed one time from after processing of order data and constraints. We have some data pattern recognition and classification procedure that is used to define if we have already trained enough model to get potential sorted combinations for evaluation with potentials, the most optimal labor cost. This is the cost required for process of all orders in some variant of designed warehouse. And the main part, the search for optimal combination task executor, consists of task managers that populate generated combination to queue, and after that, using functional execution, actually based on serverless technology, with lightweighted context, is executed using some cache data from database to reduce time for context startup. Yeah, a bit further. And here is evaluation of different approaches for computing subsystem. Here you can see 3 different ways. One was vertical scaling, like 2 till 32 cores on a single VM machine. Second one is microservices architecture with horizontal auto scaling. Depends on the loads that appear during increased number of combination tasks. And it was used up to 10 VMs, identical to the single VM. And the third option was serverless computing, as I described before, running up to 1,000 parallel functional executors. What we can see is that from the start, of course, monolith is the fastest one, but when we reach the high limit of load, up to 1,000 of combinations that should be evaluated, for the monolith it takes 1.5 minutes, for microservices 11 seconds, and for serverless, because of fast startup and less time for context switching, it takes only up to 5 seconds. Yeah, and another one very critical criteria for commerce is saving of resources. Using serverless approach, you do not need to maintain VMs or order them for permanent usage at cloud provider. So you can save up to 65% of resources, especially CPU and RAM, as network and storage space are built on a permanent manner. And here is a sample of one of our environment with evaluation for 30 days. It's sample from Google Cloud platform. And a bit further, please. Yeah, here is a demonstration of scaling and performance. Using serverless, we have another one benefit. It's predictable time of execution, and considering the requirement of customer, his priority, we could increase from time to time executors dedicated to some defined customer. And for example, for tasks with from 3,000 till 21 combination complexity, we could achieve boost in speed up to 7 times with scaling from 100 of executors to 1,000. Yeah, and here is a demonstration of UI of the system that was developed based on proposed model and approaches. It's commercial implementation, DOPWare, design optimal warehouse project. Here is demonstration of 2 different scenarios of placement racks, evaluated based. It's actually for inbound, outbound areas with some ALs and so on. And here is a list of different scenarios with calculated labor cost per each. And a bit further, the last one. Yeah, it's a conclusion. So we achieve boost in speed. We save resources, CPU from, and have more predictable time of execution And what we achieve, the main goal is implementation a new approach for warehouse design solution, because existed warehouse management and design system like SAP, Logivations, and others provides semi-manual approach that required high level of expertise, a lot of input parameters, and knowledge of user, how to configure them, how to use the system. Yeah, that's all from my side. Thank you for your attention. Maybe some questions.
Okay, Alexander, thank you for your presentation. And from my side, I can say that the question of logistics and is the question which is faced by humanity for thousands and thousands of years, and the optimality here is a very important thing. The war can be won by a strong economy and by sustainable logistics. These are the main pillars of a victory. So it was very interesting. And just maybe some short question from my side, because we're a little bit out of time. So as far as I can see, you have, like, indicated several competitors like SAP and Logivations. Yeah.
Yeah.
And whether they are, as far as I see, it's a commercial software, and it is like, what about the price of your software which you propose, DOPware? Whether it should be free, outsource, or whether it's a standalone application?
For sure, some approach could be distributed in a free way, especially for Ukraine, to support our country. But in general, yeah, it's a commercial way of distribution using subscription type. Nearly the same is used in SAP and Logivations. The difference is they try to combine different solutions in one approach, and most of customers doesn't need full package but should pay for it. And another one problem is that system are too complicated. There are even devoted industry of engineers and specialists in SAP, and without any knowledge you couldn't use it, because even integration in SAP required several months, and you would be very linked to it, so you would couldn't refuse further, because all your process would be based on it. So DFR propose solutions that from the box could design your warehouse in several clicks. You have different scenarios. You can select, maybe not on cost, but on your personal wishes, and you can refuse from it at any time. But I see people are very interested, especially in this solution, because they do not need to hire another one team to work with this system.
Okay, get it. So maybe I think it can be useful for, let's say, public companies or enterprises, or private sector, or even for volunteers right now, in order for them to do their work more effectively. Okay, thank you very much once more.
Thank you.
Thanks, Alexander.